All right, let's go ahead and take a look at your next lesson, which is on unit rates and rate tables. Head up to the top here, your table of contents. We're still working on learning goal number 40, which says you can find unit rates and unit cost using proportional reasoning. So we're not quite getting into solving proportions the way that you'll typically do it, but we're going to start getting into looking at sort of having a good number sense on how that works. All right, so two new terms for you. We have dependent and independent. Your dependent variable just means that it is dependent on whatever's going on with that independent variable. Okay, and so your dependent is going to be represented with the y variable, and your independent is going to be represented by the x variable. And so that's true over here as well. So dependent is y, and that's over x. Okay, and so you might have something like price per boxes, because the price is dependent on how many boxes you have. Okay, or you might have a cost per time over here, because the payment for you depends on how much time you spend. Okay, and so that's how dependent and independent can be phrased. All right, so let's go ahead and take a look. When you're dealing with contextual situations, meaning things that tell a story or are situational, there is a better unit rate for you to make. Okay, and so just getting practice understanding like what unit rate makes more sense is really our goal today. So let's take a look at this. We have Lily was getting ready for a pasta party. She found that she could get 7 boxes of pasta for $6. And so I could obviously represent this as 7 boxes over $6, or $6 over 7 boxes to find the unit rate. So let's go ahead and just see what these look like. We're going to do divide 7 by 6 first. So 7 is boxes. So let's go ahead and label this out over the $6. And then we know to find a unit rate, we're just going to divide it. So we would divide, just need my calculator out there. We would take 7 divided by 6, and you get 1.16 repeating. So this is on top, and the 6 is repeating, and this is boxes, because that unit hasn't changed, per $1. Okay, because we split up our 7 boxes into the $6. So that's our unit rate for that one. Let's go ahead and look at the next problem. Divide 6 by 7. So that they're actually creating a unit cost by putting the money on top. So $6 for every 7 boxes. So let's find the unit rate by doing 6 divided by 7. And we get 0.85. So I'm going to round it to 0.86 because of the 7. So we have 0.86, and that's dollars, okay, or 86 cents for 1 box. And so then you have to just look at this and go, okay, what makes more sense? Okay, she found she could get 7 boxes of pasta for $6. Do you want to know how many boxes you can get for $1, or do you want to know how much it is per box? And so that's where what you have to think about, and you should recognize that this makes a little bit more sense. I can't really have part of a box anyway, so that's really silly to me. Okay, all right, let's go ahead and look at the next one. We have Cooper uses 22 gallons of gas to go 682 miles. So let's go ahead and try both of those out. We can go ahead and do the gallons per mile first. So let's do 22 gallons for every 682 miles. Let's go ahead and find our unit rate for that. So it's going to be out of 1 mile. So we'll divide 22 divided by 682. And it divides up and tells us that we can do 0.03 gallons per 1 mile. Okay, so think about what that means. We're saying, okay, for every 0.03, for every 300ths of a gallon, I can go a mile. Okay, you can decide if that sort of makes sense to you. Let's go ahead and switch to the next order for the ratio and do 682 miles on top and the 22 gallons on the bottom. We'll create that unit rate by doing 682 divided by 22, and we get 31 miles per gallon. So just think about that. What do you normally hear in life? Do you hear gallons per mile, or do you hear miles per gallon? Okay, and so again, this is the one you should be recognizing as the better choice for a unit rate, because I want to know, if I know that my car holds 10 gallons, it's really easy for me to figure out how many miles I can get by looking at the actual miles per gallon. Okay, this is what they share with car dealerships and things like that. So which seems more useful to you and why? Obviously, we just talked about that. So for this particular problem, we would say miles per gallon are more useful. Let's do an F. Because it tells me how far I can go per mile. Okay, which is more reasonable to understand. All right, this bottom section is rates as tables. And so what you have to really understand is that they really just are fractions. So don't let the table complicate things. Okay, when you're comparing rates and things like this, here's your numerator, here's your denominator, or it could be the other way around based on what they're asking for. But if you're checking if something is equivalent, okay, we're just looking at it almost like this. If you made fraction bars, and we're checking this fraction of 1/4 over 1/2 and comparing it to this fraction and so on. So that's the basics of what this actually is. The reason this is 0 and 0 is because it is real life situation. So when you have 0 time, you have 0 distance. So it's almost irrelevant data. Okay. All right, but let's go ahead and test this out. It says, I want you to find the unit rate for this particular table, but they want you to find it in the miles per second. Okay. And so we talked about up here that the top is always going to be the dependent. Okay. So the top is going to be our y, and the bottom is going to be our x. So, and they said miles per second. And so for this one, y is going to be our top, and x is going to be our bottom. Okay. And so it's reverse. You just have to be aware of that. Okay. And so we'll go ahead and you may even want to write that over here somewhere. Y over x is how the order that we need to do this particular table. All right, so when we're trying to figure out the unit rate, I would probably just look which one would be easiest to do. I mean, these have mixed numbers, so I don't really want to deal with that. So I'm going to look at this section right here, and we're going to go ahead and just create our ratio or create our fraction. So it needs to be y over x, or you can just focus on the language miles per second. So miles has to be on top, so that's 1/2 for every 1/4, and you want to give it its label. So 1/2 miles for every 1/4 second. Okay, and then we want to create that unit rate. We know that to do that, we're going to just divide them. So it's 0.5 divided by 0.25, or you could multiply by the reciprocal. I'm just going to go ahead and do 0.5 divided by 0.25. And we get a unit rate of 2 miles per second. And so there we go. Now, you could go through and check more of them to make sure that you're correct. I'm just going to check one more to verify it, and then that's it. Okay. So again, miles per second. Let me change colors here. We're going to not use a mixed number here, so we'll do 4/3 instead. So we have 4/3 miles over 2/3 seconds. We can go ahead and multiply by the reciprocal. And so I'm doing 4/3 times 3/2. We can cross simplify here. Divided by 2, divided by 2, divided by 3, divided by 3. And you can see if you multiply straight across, you actually get 2 miles per second again. And so we verified that this is accurate. So the unit rate is 2 miles per second. Okay. All right, let's go ahead and look at this last one. This one's a little bit different. Technically, you would probably want to set up a proportion and solve it. We just haven't got to that quite yet. So let's go ahead and just use some mental math to solve this one, since it's a pretty straightforward unit rate. So our unit rate for this is 2 gallons. I'm going to write it like this, for 1 lawn. Okay. And so we know that's up here. So 2 gallons for 1 lawn is right there. And so we need to fill out the rest of our table here to help us think through things. So if I know that 2 gallons covers a whole lawn, then half the amount of gallons, meaning 1 gallon, is only going to cover half of the lawn. Okay, so we're just sort of thinking through that. And so if I do half of that, or have half of those gallons, then I also know that half of a half is a fourth. Okay, and then if I have 0 gallons of gas, I'm not mowing any lawns. Okay, if I'm going the opposite direction, if I know 1 gallon of gas can do half of a lawn, we're just going this way, and it looks like we're gaining a fourth of the lawn for each half gallon of gas. And so we would end up with, we have 1/4, 2/4, 3/4 lawn mowed. So I'm just using some common sense, reasonableness, mental math to solve that out. We'll show you a more guarantee way later. So let's go ahead and look at the unit rate for this, but they want us to identify the unit rate of lawns per gallon instead. And so I'm just going to pick one of them, and instead of doing gallons per lawn, I'm going to do a lawns per gallon. Okay, and so here's a nice thing. I actually already know that it's 2 gallons for 1 lawn. And so if it is reversed, okay, and I set up 1 lawn for every 2 gallons, we can just do that division real quick. And obviously 1 divided by 2 is going to be 0.5. And so I can do 0.5 lawns per gallon. Okay, or I can write it up here like this. Lawns per 1 gallon. And so there's my unit rate in that situation. But I would never really worry about how many lawns I can do per gallon of gas. I think I would prefer to know that the 2 gallons of gas is what I need for each lawn. All right, that is that section. If you have any questions, let me know.